This is for Algebra 1. In the last lesson, we started looking at quadratic functions and what their graphs look like. I want to take just a second and remind you some things that help it to be easier maybe to see what your graph is actually going to look like. So let me get a graph going. Squared plus 3. Let me clear this out. Okay, so if I my starting point, and sometimes you can just hit graph and that's fine. But a lot of times I like to start by going zoom 6. And zoom 6 is a standard screen. This window is going to go 10 in each direction from your origin. So it's counting out 10, left 10, down 10, up 10. We can't see anything. So when you go to zoom 6 and you can't see anything, the next option is probably go to zoom 0 for fit. And it's going to force the graph to fit somewhere on your screen. So now I can see something. It's better, but I can't really see the bottom, so I'm going to zoom out now, which would be zoom 3. The thing you've got to realize is when you're zooming out, it won't actually zoom out until you press enter. And so now you can pretty well see it. Okay? So that's just a good starting point when you're trying to look at your graph. So a reminder, a quadratic function is a function that has an x squared. There is an x squared anywhere in there, it's quadratic. When you look at the graph, it's called a parabola, and it can open up or it can open down. We talked about the fact that when it opens up, it has a minimum, and when it opens down, it has a maximum point. That's called your vertex. Okay, now these arrows are a little bit messed up. Your solution should point here, and your vertex is going to be this point down here. Okay, that's your vertex. And it's either a minimum or a max. On this one, it opens up. Your vertex is a low point, therefore it is a minimum. But what we're going to focus on today is solving and finding a solution to your quadratic using your calculator. Now, you need to understand that quadratics should have two solutions. All of them. Now, you may have what we call a double root, which means both solutions are the same thing, but they should have two solutions. It's possible that we would have no real roots, okay? So let me show you some examples. Your solution is also called a root, it's also called a zero, and it's wherever the parabola crosses the x-axis. If it does not cross the x-axis, then we have no real roots. So, if you had a graph like this, you have 1, 2 roots. If you have a graph like this that never gets down to the x-axis, that will be your no real roots. Okay? It's not that there's no solution, so don't tell me no solution. It's that they're not real. They're imaginary. They have an I in them. If you had something that looked like this and it only touches it once, then you have one root. This is where you have your double root. Okay? Doesn't matter whether it's opening up or opening down. What we care about for your solutions is where it crosses the x-axis. So, to graph a quadratic function on your calculator, you're going to get y by itself. You're going to go to y equal, and you're going to punch your problem in. You want to go ahead and put a 0 at the second line, which is y2. Okay, put a 0 there. So then you can look at your graph. You may want to kind of figure out how it's looking, if we have a maximum or a minimum. So once you know that you can see the graph, you're ready to actually find the answer. And the way you do that is you do second calc 5 for intersect. We're looking for where the lines are going to cross. Once it draws the graph, you're going to press enter, enter, enter. Okay, you're going to get an answer. Then you're going to have to go and do it all over again, second calc 5, to find the other solution, meaning that you've got to find both places. Now, if all you do is second calc 5, enter, 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 and then second calc 5, enter, 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 you're going to get the same answer both times. The second time you do it, before you do the enter, 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 you've got to move your cursor to where the lines are crossing at the other spot. And I'll show you what I mean here in a minute. And then remember, to find the vertex, you're going to use second calc and either max or min. Vertex, you can do some rounding. Solutions, I don't really want rounding. So let's look at one. Number 1, solve the following by graphing and then find the vertex. So we're going to start by going to y equal and clearing everything out. And we're going to say x squared minus 2x minus 3. And we're going to go ahead and put a 0 at y2. So to find our solution, we're going to go second, calc. We're going to choose number 5 for intersect. Give it a minute so that it can draw. Enter, enter, enter. And your first solution is -1. So -1, and then we're going to do this again. Second, calc, 5. I'm going to go to the right. I'm really not sure where the other solution is. I'm taking a chance here. Enter, enter, enter. And I got a different answer. So x equal 3 is my other one. And you can do x equal -1, x equal 3, or you can say -1 and 3. I will take it either way. We also have to find the vertex. This is a low point, which means it's a min. So we're going to go second, calc, number 3 for minimum. Move your cursor until you are to the left side of that low point. There's not an exact place that it has to be, just somewhere to the left. Press enter. Go to the right until you get on the right side. Keep in mind that once you have ever started working on your graph and you've pressed enter once, you will only go left or right. You will never go up and down. So I'm to the right, so enter, enter. And my vertex, I'm going to round that to 1, -4. And remember that your vertex is written as a point, therefore it's in parentheses. Okay, so that has us finished with number 1 and ready for number 2. So I'm going to go to y equal. I'm going to clear it out. We have x squared plus 9x plus 5. Leave my 0 at y2. Second, calc 5. Let it draw. Enter, enter, enter. And we have negative, and I told you not to round. Sometimes you can a little bit, okay? -0.59. Now, to be honest, I really don't like this graph, so I'm going to go zoom 6 and just see what it would look like if I changed it. And that's a whole lot better in my opinion. So I'm going to go second, calc 5, enter, enter, enter. And that was the first one. I've already written it down, so I've got to do it again. Second, calc 5, and I'm going to go over here to the other place that it crosses the x-axis before I press enter. You don't have to be right on it, just closer to that one than the one we already did. Enter, 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 and -8.4. And -8.4, and that will be our solutions. So now for the vertex, it's a low point again. So second, calc 3 for minimum. I need to be to the left of the vertex or the low point. I can't see the vertex, but I can tell I'm at the left of it, so it's all good. Press enter. I'm going to go to the right until I see my cursor come back up on the right-hand side, and I'll know I'm past the vertex. Enter, enter, and that's going to be like -4.5, comma -15.25. -4.5, comma -15.25. If it's just kind of what we would call a normal decimal, go ahead and leave it and don't worry about rounding. And that's all you have to do for number 2. So that takes us to number 3. We're going to go back to y equal, and we're going to clear out y1. And we have x squared minus 12x plus 36. And we're leaving the 0 at y2. So second, calc number 5 for intersect. We'll let it draw. And we have enter, enter, enter. And we have 6, 0. So we would say 6. And then we would go second, calc 5 again. Go way over to the right. Enter, enter, enter. And we got the same answer. So I would try it one more time. Second, calc 5, and go way to the left. Enter, enter, enter. And I'm still getting 6. So what this tells me is this is the one that is a double root. Okay, it only touched it once. We have one solution. That would be 6. So now to find the vertex, it's a low point, which is a minimum. So second, calc 3 for minimum. Go to the left. Press enter. Go to the right. Enter, enter. And that's going to be 6, 0. So that's also kind of proving that I only have one root. If the vertex is at 6, 0, and that's where the root is, it's not going to get any lower. It's not going to cross the x-axis a second time. Okay, number 4, go back to y equal, clear out your y1, and we have x squared plus 2x plus 5. And we're going to go second calc 5, let it draw. And we're going to go enter, enter, enter. And it tells me no sign change. When it tells you no sign change, it says, I can't find where these two lines are crossing. It might mean that you need to change your zoom. It might mean that they don't cross. So the first thing you should do is look at your graph. And hopefully you noticed this as it was drawing. It never gets down to the x-axis. Okay? As you're working with your graph, this is the low point, x-axis is down here. It does not get there. This means that your solution is in RR, no real roots. There are solutions, but they're going to have imaginary numbers in them. Okay? Still can find a vertex though, and it's a low point again. So second calc min, go to the left, press enter, go to the right, enter, enter, and -1, 4. -1, 4, put parentheses because it has to be written as a point. Okay, going to the back of your handout. Looking at number 5, graph an equation with roots 0 and -6, and a maximum point is -3, 4. So your roots are going to be where it crosses the x-axis. Okay, this is the x value. So go to where x is 0 and you put a dot. That's a root. Go to where x is -6 and you put a dot. 1, 2, 3, 4, 5, 6. That's another root. Then you're going to plot this point, -3, 4. So 1, 2, 3 left, 1, 2, 3, 4 up. You have to have a parabola, curved line, that goes through those 3 points. So it's going to be something like this. Put arrows on the end. Doesn't have to be perfect, but needs to look realistic, okay? And that's all you have to do. Looking at number 6, your roots are 2 and -5, so we go over to 2 and we make a point. And we go to -5 and make a point. So 1, 2, 3, 4, 5 to the right. Your minimum point is -1, -4. So left 1, 1, 2, 3, 4 down. This is a minimum. So it ought to look something like this. Once again, it doesn't have to be perfect, but you need to get the basic idea. You need to have those 3 points plotted, and they need to be plotted correctly. Okay? So that's how you can make a graph based on the solutions and the vertex. Okay? That's all for your notes. You're ready for your assignment. If you have any confusion about anything, you need to talk to me.